Welcome to the GobiWeb video training series. In this tutorial, we will demonstrate how to carry out differential methylation analysis across annotated genomic regions. For this tutorial, we will use a publicly available mouse colon epithelial dataset, GeoAccession GSE26758. In this dataset, DNMT3B transgenic mice are induced with tetracycline and colon epithelial DNA extracted from these mice, as well as control samples. There are 3 biological replicates in each group. The samples were subsequently sequenced using the Reduced Representation by Sulfide Sequencing Protocol, RRBS. These samples are then uploaded to GobiWeb and aligned using the last aligner in the bisulfite alignment mode. In this tutorial, we will demonstrate how to carry out differential methylation analysis at CpG islands between the induced and the control group from Gobi alignments. All cytosines in a particular context, in this case the CpG context, are summarized and the methylation rate is estimated for a genomic window, that is the boundaries of the CpG islands. We then carry out a statistical test for the differences between two groups. To start this analysis, we navigate to the Actions menu. We select Compare Groups of Samples. This brings up the Compare Groups of Samples wizard. The first step is to define a description for your analysis. This must be meaningful text so you can always trace back what this analysis was all about. Here I'll call this DNMT3B induced versus control over CpG islands. Under Analysis Type, we select Methylation Analysis over Annotated Regions. Our organism is mouse, so we select that, and under Reference, we select the reference genome. In this case, we aligned against MM9, so we select that. We have 2 groups, and now we'll set up the analysis configuration parameters. If you're unsure about what a particular parameter means, you can select the help bubble here to the left, and this will provide a short description of that parameter or that analysis. Our type of analysis and output format is methylation. Q-value threshold refers to false discovery rate correction for the statistics. You can select this to be 1. This will output all features regardless of their p-value or q-value, corrected p-value. The number of top hits reports 10,000 results if there are no results that meet the q-value threshold. Minimum variation support. This is the number of reads that support a particular site methylation call. And most importantly in this analysis, annotations. We have a predefined set of annotations to estimate methylation over. Here we're demonstrating over CpG islands, but you can select genomic tiles, UTR regions, promoter regions, intronic regions. You can also alternatively combine all those regions and output one table. It's also quite useful, this parameter, write CMC columns in the output file to report the counts of methylated and unmethylated Cs. So we'll set that. And GobiWeb implements an empirical test for differential methylation between groups. You can estimate this p-value by selecting this box. The p-value combination method refers to this empirical test, and median is the current recommended approach. Cytosine contexts, we want to consider the CpG context here, but you can also consider any Cs in any other context. Again, you can share your results of the analysis with other GobiWeb users by configuring this here. A detailed tutorial is also available on sharing. The next step is to define groups. So we start with define group 1. Our group name is control. We select the alignments in the control group. So here, last alignment of the DNMT3B control samples. Okay, so we define the second group. This is the induced group. I'll look for the alignments here and select those. And then we define comparisons. In this case, we only have two groups, control versus induced, but you can imagine you can extrapolate that and have multiple groups and do different pairwise comparisons. So we select control induced as the comparison pair. Then lastly, there's a verification step. Here you check that you've configured your analysis correctly. You check your description. You check your organism and the reference genome. You check your analysis parameters. Make sure everything is as it should be. Most importantly, once you start to have a lot of samples, make sure that all the samples are assigned to the correct group. So here I checked induced, great. So now you save the analysis. This creates a unique job tag. That analysis is set up in the system and the job is sent to a compute grid. You can monitor the status of the job by looking at the job status. The job is currently running. You can refresh the status by clicking these two arrows, and the progress is reported under status history. At different times, you see different events occurring. You can also monitor the job status by going to Browse and selecting Methylation Analysis. Here's a table of your job history. If you select this job we set up, you can then come back and monitor the status in that way. You'll know the analysis is completed. The job status will update. And under completed analysis, you'll be able to download the results table either as a TSV file or an IGV format file to visualize in the Integrative Genomics Viewer. You can also browse the table statistics, which is a tabular form of this TSV file. Here's the results table. For each row, you have a CPG island. Here under feature column is an ID, so weak CPG island on chromosome 9. You can see that across the table you have different columns here, the number of Cs, so the number of sites, the number of unmethylated Cs in the DNMT3B control sample replicate 3. If you want to know all the columns in the table, you can view them under the heading All Columns. This lists all the columns in the table. Visible columns lists the columns that are currently displayed in the table. You can filter the table to output the columns of interest. So let me just start over here. Remove all the columns, click Show or Hide. So now to set up the table that you would like, I'll select the columns I would like to output. So I select the primary key, chromosome start end, and the feature columns. I want to output the methylation rates for each sample, for example. So let's say methylation rate columns, 6 samples. So I put those across, and then maybe some statistics. So I want to output the delta MR, so that's the difference in methylation between the control and induced group, and the empirical p-value, and the Fisher-corrected, Benjamini-Hodgberg, FDR-corrected q-value for the comparison. So if I show or hide those columns, this outputs that subset of the table. So that's interesting. So you can also filter the table. Here, let me filter by the empirical p-value. So I want any CPG islands with an empirical p-value less than 0.05. So we see that our table is filtered, and now we have only 4,000 entries from 12,000 entries, the most significant sites. So you can also sort the table as well. I'll sort by the maximum difference between the two groups, so the delta MR. So in descending order. So our top ranked feature is this island on chromosome 14. If you're satisfied with your filtered table, you can download this as a TSV file. Or as you saw before, you can download the full table from the analysis results page. This concludes our tutorial on differential methylation analysis over genomic regions. For more information, please visit our website at gobiweb.compagnonlab.org.